Okay, welcome guys. Welcome back to our tutorial. Today I'm going to show you how to solve this exercise 5.2, especially involved with the sigma notation problems. In this particular question, they don't really give you like in terms of numbers, but they give you in terms of variables. So therefore, you really have to be careful when involved with variables. So basically, it's not quite hard because all you have to do is that you look carefully at these terms here, and you replace whatever the terms here with the particular equation in order to find the summation, the one we just learned previously. So for part A, you need to show that the summation for this particular terms, general terms of R, from R5, and you have to stop at 2n minus 1 terms. And whatever you are going to get on the left hand side here definitely must be equals to the right hand side, which is 2n squared minus n minus 10, for this condition where n greater than equals and greater than 3. Because of what? If you replace the 3 to this upper part here, you're supposed to get greater value than 5. Okay, so you cannot have something that the summation from R5 up to lower number than 5. Other approach, you can rewrite the sigma notation like this. Okay, so we have a sigma notation of 2n minus 1, this one starting at R5 for these general terms. Remember, you can rewrite sigma notation into the form where you always start with R1, so that you can easily identify what is the n for this particular sigma notation. So this one here, if you sum from R1 equals to 2n minus 1, okay, you can simply subtract or minus the summation from R1 up to, because we want 5th term to be included in the summation but not the 4th term, so you have to stop up to 4th term for this R. So basically you must get this one right in order for you to get the correct answers later on. So if you familiarize with this type of, when you start the sigma notation starting with R1, so you can easily find the n will be whatever the numbers or terms at the top here, so you don't really have to worry. But if you have the R which does not start at 1, therefore you really have to be careful, because whatever the terms at the top here is not going to be your n. You really have to be careful, because this is the formula to find the summation. N over 2, what is your first term, plus your n terms, and will be the same for this part here. So now you really need to find what is n, because we already changed this one into this, I can call this one as standard form, because we start at 1. Therefore your n will be 2n minus 1 in this case. So divided by 2, then what is your first term? Your first term for this particular sigma notation, when you replace R1 to these general terms R here, so simple. So your first term will be 1. And your n terms will be, because we are going to stop at 2n minus 1, so your n terms will be 2n minus 1. You really have to put a bracket, because whenever we involve with negative sign later on, so you know that you have to distribute this negative to whatever inside the bracket later. So same thing will be here, because this one just deal with numbers, so it's quite straightforward, because what, n will be 4 divided by 2, your first term will be, when r equals 1, plus your nth term will be definitely be 4, because you're going to stop the summation at 4. So all you have to do, simplify this version until you manage to find that the answer will be the same as 2n squared minus n minus 10. Let's have a look. So this term here, 2n minus 1 divided by 2, so this one can cancel, because 1 minus 1, so you end up with 2n. This one here, if you try to cancel 4 divided by 2, you're going to get 2. So 2 times 5, you're going to get minus 10. So I'll put this over here because I need to show you guys. So this one here, basically 2, with 2 here, I can simply cancel this one, so you're left with n. So if you distribute this thing here, okay, you are supposed to get 2n squared minus n minus 10. Then this will be your correct answer. You have to compare with these terms here on the right hand side here, which is 2n squared minus n minus 10. So then you can really show that this one is correct. So for the next video, I'll show you how. Let's have a look how to solve this one without having rewrite this sigma notation to the standard form, or you need to rewrite this one into the separate two sigma notation or sigma terms. All you have to do, I love to call this one as the method of shortcut method. Because of what? Because you need to find out exactly what is your n terms, what is the number of terms, okay? Or in this case, you need to find what is the n. Make sure you understand that if you start, whatever the numbers doesn't start at 1, so the upper part here is not directly your n. Therefore, you just have to remember like this. Okay, let's say if you have the summation of 5 up to 10, for example. So do you know that the n will be your how many terms do you have? Many terms. So from 5 to 10, I want to ask you how many terms do you have. So it's not simply it's 10. Definitely it's not 10, because you only have 10 if you only start with 1. But if you minus 10 minus 5, you are going to get 5. This is what almost majority of the students make mistakes when they try to minus the upper value to the lower value, because you're not going to get a number of terms, okay? Because if you try to count 5, 6, 7, 8, 9, 10, you are supposed to get 1, 2, 3, 4, 5, 6 terms. So if you have a 6 term, therefore your n is supposed to equals to 6, not 5. Therefore, in order to find what is n value, the quickest way or the shortest way is that whatever the value at the top, like for this example here, we have 2n minus 1, this one r5 for r. So you need to identify your n. Therefore, your n must be whatever at the top here, 2n minus 1 minus 5, and you have to do one more step, which is always plus another 1 terms. So in this case, 2n minus 1 minus 5, you are going to end up with 2n minus 5 will be your number of terms. So if you try to substitute into this formula, n divided by 2, a, your first term, but your first term is no longer when you substitute r equals 1, but now your first term will be a sub 5. When you substitute the value of r equals to 5, that will be your first term, because you start counting from r equals 5. While your n terms, you really have to be careful here, because your n terms will always be 2n minus 1. Okay, so 2n minus 1. Therefore, it's not 2n minus 5, because 2n minus 5 is your number of terms, okay? Because your last term will always be 2n minus 1 in this case. So just substitute what you said n, so 2n minus 5 divided by 2, so your a5 will be 5, which is 5, plus 2n minus 1. Okay, so this part here, 2n minus 5 divided by 2, so this part here will become 2n plus 4. Okay, distribute this thing here, so you will end up with something like this. So it's up to you. You can just factorize this one first, and then you can cancel out with 2, and then later on you just expand them together. I'd love to do that way, because it will be much easier for me to do a divided by 2, so the expansion will be 2n, so n plus 2. Okay, n plus 2. So basically I can cancel the 2 over here, so the rest onto the expansion. 2n minus 5 will be n plus 2, so it will be 2n squared plus 2n minus 5 and minus 10. Okay, so this one will be 4n minus 5n minus 10, so we can further simplify. This one becomes minus n minus 10. So this is definitely will be the answer, because the left hand side equals to the right hand side. I think it's pretty much about how to solve the question regarding the simulation for part A. Thank you for watching, guys. I'm your maths instructor. Till then, see you guys next time.